Hey class, let's talk about classes of synovial joints. As we look at synovial joints, we have 6 total classes. We have ball and socket, condylar, saddle, plane, hinge, and pivot. As we look at these 6 classes of joints, we're going to spend some time talking about each of them individually. As we look at a ball and socket joint, and this for me is one of my personal favorites. We have a hemispherical head, aka the ball, and that hemispherical head will fit into a cup-like socket. Classic examples include the shoulder and the hip. These are the only multi-axial joints in the body, which means that they have 3 planes of movement. As we look at ball and socket joints, there's trade-offs here. We have the most degrees of freedom, we have the most movement, and we also are going to have a lot of injuries associated with those degrees of movement. As we look at our next kind of joints, they're referred to as condylar joints, formerly known as ellipsoid joints. These condylar joints are going to be a oval convex surface on one bone, and then the other bone is going to have a complementary depression on the other. So we can have a oval convex surface, a condyle, and condyles, as you remember from lab, are rounded projections associated with joints. On a bone, we have medial and lateral condyles on many of our long bones. And then we are going to oftentimes have a fossa on the other side, and that fossa is a complementary shaped depression. These condylar joints are biaxial joints, meaning that they give us movement in 2 separate planes. Some examples of these include the radial carpal joints between the radius and the carpals, or the metacarpal. That's a mouthful right there. There's a tongue twister. I'm going to say it slowly. Metacarpophalangeal joint. There we go. Metacarpal phalangeal joints. So these joints are going to give us multiple planes of movement. As I'm just wiggling my finger right now, I'm like, yep, I can definitely have multiple degrees of movement, or 2 planes of movement with these joints. Although I will admit, one plane has a lot more movement than the other plane. We also have saddle joints. Saddle joints are when both bones have an articular surface that's shaped like a saddle. And one saddle is going to be concave, one is going to be convex. So here is a classic saddle joint. A saddle joint is a biaxial joint commonly associated with our opposable thumbs. So here we can have the carpal bone as the convex part of the saddle. Then we have the carpal bone as the convex part of the saddle. We have the metacarpal right there as the concave part of the saddle, and that is going to give us 2 degrees of movement, so they are biaxial joints. And these saddle joints are biaxial joints where we have nearly equal degrees of movement in those 2 planes. We also can find saddle joints at the sternoclavicular joint, and this particular saddle joint is going to be between the sternum and the clavicles. And this saddle joint doesn't have as large of a range of motion compared to the trapeziometacarpal joint, aka the thumb joint. We also have plane joints. Plane joints have previously been referred to as gliding joints. Gliding is more of a action-oriented name. Plane is more of a structurally oriented name. And I say that because when we look at the plane, the planes are going to be these flat articular surfaces. And the bones, so here we go, right there, there's a plane between the 2 carpals of the hands. These planes are going to allow for mild movement, or a mild range of motion on 2 planes of movement. So they're biaxial joints. So between the carpals of the wrist, tarsals of the ankle, or articular process of the vertebrae, we have plane joints that are present. We also have hinge joints, and this is another one of my favorites. I like hinge joints just because they're monoaxial joints, and these monoaxial joints were one of the easiest ones for me to comprehend when I was a student. So these hinge joints are going to have a convex surface paired with a concave surface, and they're monoaxial, and they typically have a large range of motion in that one axis or along that one axis. And because they're monoaxial, they tend to be structurally much more stable than the biaxial or multiaxial joints. A classic example of these monoaxial joints include elbow, knee, or within in between the phalanges of the fingers or the phalanges of the toes. We also can have some pivot joints. I'm going to switch to red here for the pivot joint. So here we have the pivot joint, and the thing about a pivot joint is that it's the bone of a pivot joint spins along its longitudinal axis. This is the key characteristic of a pivot joint. The radius and ulna is a good example of a pivot joint. So where the head of the radius, it looks kind of like a mushroom to me, meets the ulna right here, it can pivot along its longitudinal axis, or the lengthwise. I'm going to make a dotted line here. The longitudinal axis goes the length or the long axis of the bone. We also have the atlantoaxial joint, where C1 pivots along C2, so where the atlas pivots on the dens of the axis of our vertebral column, and then the other classic example of the radio-ulnar joint within the elbow. That's all we have for this recording class. If you have any questions about the 6 classes of articular joints, please feel free to shoot me an email or to post them on the class discussion boards. And as always, happy studies.